Hello, my name is Maxim Marinenko. I'm one of the developers of our virtual laboratories. This year, All Russian Science Festival Nauka Zero Plus takes place in an unusual, mixed format. We combine in-person and remote activities. I want to present you our online virtual laboratories, where you can conduct experiments by yourself in virtual reality. Thus, you can get a better understanding of how real research is conducted. Our journey begins, as it happens, with a briefing. A distinctive feature of our virtual laboratories is that you can interact with various objects, activate mechanisms, and participate in experiments. On the startup screen, you can see instructions on how to perform these activities. If you want to move to another room, use a portal. Now we are in the central hall, where you can see all the different portals. You can pick the portal you want to visit a room connected with a field of research or an activity. Let's start with something easy, for example, the solar system. Here we try to recreate the solar system as it is, to demonstrate the vast distances between the objects, and also to provide information on these objects. In our next updates, we will add new features and add some new information on the planets and the Sun. By walking through a portal, you can return to the central hall immediately. Let's do this. After we have wrapped up with the solar system, let's visit another hall. One of the most important topics of this year's festival is medicine. In this hall, we try to convey to our guests the way scientific medical research is conducted. For example, here you can see the multi-track navigation system. Its model, of course. It was developed by a group of scientists, including some scientists from the MSU. By using it, surgeons can perform navigation during a surgery or in preparation for it, which is even more important. By using it in preparation, a surgeon, or a neurosurgeon specifically, can pick an intervention method which is as non-invasive as possible and as short as possible. Over here, you can see a set of computed tomography equipment, which can be used, for example, for examining the lungs of a patient. These are real images obtained through computed tomography of the lungs affected by a disease. This, for example, is one of the most precise methods of diagnosing the coronavirus disease, and this is the way this disease manifests itself to the doctors. The disease, in fact, is diagnosed by examining its consequences, which the doctors see through computed tomography, which we see here through this visualization. To ensure the correct operation of this visualization, we put this in our virtual laboratory and allow you to interact with all of it. All of the features which you see now through my eyes, so to say, you can also see through a VR headset. In fact, some of the halls have special features available only for VR headset users. These features provide a more thorough explanation of the demonstrated processes. Let's not move far from medicine and visit a hall dedicated to an adjacent field, psychology. In this hall, supported by... Oh, look, we have a guest here, Maria Zinovieva. She is scheduled to give a lecture In this very hall, you can see the timetable of our lectures on our social media. This hall is largely based around the concept of illusions. Here we demonstrate some illusions, the object used to create these illusions, as well as the practical applications of psychology. We also demonstrate the methods used in psychology. Here you can see the footage from the three-pyramid experiment. This experiment was conveyed in order to define what is truth and to see how the society influences our decisions. Well, a member of the society, this boy, you can see. I won't tell you the results of this experiment. You can find out the results by visiting this hall tomorrow or any other day.
Например, завтра или в любой другой день. Сейчас мы не будем заострять на этом внимание.
We use this hall to demonstrate other experiments which were used by psychologists in the past or are still used today. And not only the experiments conveyed on people, you can see here the worldwide famous Pavlov's dogs, for example, or the cat experiment. This cat represents the famous Thorndike's puzzle boxes. There isn't much active interaction in this hall. It was built to make you feel like an active participant of a psychological experiment, which is in fact an observer. While observing these experiments, as psychologists do, you can formulate your own opinion on the results.
Соучастником эксперимента, то есть чтобы он сложил свое мнение о каком-то процессе, пока он еще идет.
After learning the results of psychological experiments, let's participate in one. For example, by visiting the biology hall. Biology is a very popular theme in schools and youth clubs. Let's go through the biology portal. We are in the biology hall. It is a vast space dedicated to several themes at the same time. In the first room you can study animals, insects to be precise, which inhabit various regions of our planet. Second, the radio park, which we will visit later. Third, a very interesting laboratory dedicated to the anatomy of arthropods. This is a model of a crayfish. Virtual reality technologies allow us to study its anatomy right here, to study it in depth, to count up the elements which comprise the crayfish's body. This experiment can look terrifying, but through it we understand that nature is in fact much simpler, which we could have thought. Each part of the crayfish's body in our laboratory is a separate element, which you can touch, which you can move away and model, then restore itself. What we see here is a part of hands-on seminars conducted in Moscow State University. If you are soon to graduate from high school, you can imagine being a student of the MSU. This model is quite detailed. We can see not only the legs, but also the internal organs of the crayfish. If you prefer more conventional ways of learning, you can look into the screenshots from traditional scientific literature presented on the walls and to read more about our anatomic model. In some halls, such as here, you can see the images of real people who helped to create these virtual laboratories or to test them. Hello, dear guests of the festival. My name is Anna. I'm the technical director of Pilgrim, a seasonal biology school. I study for PhD at the biological faculty of the MSU. I would like to tell you more about the ways 3D modeling can be used and are used right now during biology studies in schools. As you can hear, Anna can tell you about the ways biologists from the MSU help school projects and work on applied projects in the university. Let me remind you that if you want to visit our virtual space, you can do so by installing the necessary software from our website. Now let's visit the room dedicated to Zarate Park. By using this technology, we can grow plants in air without using any soil. It is the result of cutting-edge research. You can listen to the speeches by our lecturers tomorrow. Now let's take a walk around Zaratia, our virtual Zaratia. The real park is open now, but the access is limited, as for now, through our virtual reality, through the panoramic views and the recordings of the lectures. You can visit the places which are not really accessible now.
Популярном формате. Точнее, которые доступны сейчас меньше, чем были доступны раньше.
Let's exit this area.
Так, ладно, откуда мы идем?
В воздушной среде без использования почвы. Это результат передовых исследований в области биотехнологии и агрономии. И также это первый подобный объект на территории Российской Федерации.
So we have visited the biology hall. Let's visit one of the most picturesque area in our virtual reality, the Ross Atom Hall. Thanks to our partnerships, here you can see the models of some of the equipment based on nuclear technologies. For example, this is the model of a nuclear bomb, the first Soviet nuclear bomb, and also separately the core of this bomb. All of these models are available in different places. You can interact with these models and read more about them. The information is available directly on the models or on the displays close to the models. Look, someone has moved away the core. Let's move it back to where it should be. Another important model here is the Soviet nuclear-powered icebreaker Lenin. For now you can only look at this, but I hope in future we will let you drive it. I think many of you have dreamed of becoming sea captains, especially an icebreaker captain. This is possible through virtual reality. This, I believe, will become a perfect example of using virtual technology to educate a journey through the Arctic Ocean on a historic icebreaker. From nuclear technology, let's go back to medicine, and not just medicine, but bioengineering. We are now in the halls created in partnership with N+ Group. Let's go to this room in particular. It is dedicated to biofabrication of internal organs. Here you can create a tissue of an internal organ. To do this, we should build the structure of a tissue. To build the structure, we will make use of magnetic levitation. By using biofabrication, you can build any internal organ. We will be building a blood vessel. We're going to be building it from tissue spheroids. This is quite a long procedure,
тканевых сфероидов.
as you can hear from our expert over there.
Согласно информации,
This
которая
procedure can take up to
на то,
24
чтобы ее собрать,
hours.
может уйти до суток. Мы сейчас только несколько
We
попробуем
won't be
технологию на деле,
losing
а
that
так
much
эта
time.
активность позволяет
We'll
использовать
just
ее
try it
в
out.
мультипользовательском режиме.
This model can be interacted with
Вот я начал
by
собирать,
multiple users at once.
проверяю на
I've
сборку.
started doing it. Let's check whether
Трубочки
we've
не
done it
собраны.
right.
Тем самым
Vessel not built, as we can see there. Other users should pick up that work and build the vessel completely. This type of vessels can be used in real medicine. This technology is only under development, but I believe that in future we'll build new internal organs through 3D bioprinting, through biofabrication. Thus we will need fewer internal organs from donors. In this very same area, you can see the room dedicated to laser technologies. The research group are working as a joint collaboration between the MSU and the Russian Quantum Center in Skolkovo. Our group is led by Alexey Mikhailovich Zholtikov, a leading expert in nonlinear optics and laser technologies. Our group consists of talented researchers with PhDs in physics and mathematics. Besides biological and laser technologies, in a smaller room over there, we demonstrate you the way cloud technologies work. This is a relatively simple model, but still it gives you an understanding of the amount of the equipment and the room it takes to run, for example, a virtual laboratory like ours. Without data centers just like this one, all of our virtual laboratories would not run. It would not be possible. Practical applications of these laser technologies include remote sensing and spectroscopy. What are the other fields available to us? In this room you can study gravity on different planets. In this room you can see the laboratories supported by Russia Science Foundation. Some of these laboratories are located at the MSU. Obviously, this virtual set wouldn't be complete without halls dedicated to mathematics and physics. In those rooms we try to demonstrate how complex scientific concepts can be understood through directly observing the experiments. Another hall is dedicated to the modern technologies in the field of telecommunication. We answer the question why we need 5G technologies, how they will be used for humanity.
Также мы пытались показать то, как выглядят современные технологии в области телекоммуникаций. То есть зачем нужны современные 5G технологии, почему это нужно и как это применяется во благо человечества.
Next, let's visit the hall built by Murphy University. It has a number of interesting sets. These sets are dedicated to professional training. I am not an engineer, this is a complicated field for me. I hope tomorrow we will have a specialist here to go into the details. The experimental sets you see here are used for training the students. By using models such as this one, students learn to apply their knowledge at workplace, at facilities dedicated to nuclear or chemical research, for example. Virtual reality spaces help to save time on training when students arrive at the facilities. The potential workplaces here are a research institute or a nuclear plant. Some of the functions we enjoy here cannot be possibly introduced in reality, such as, for example, this button which visualizes the radiation level. After pressing it, we hear that the radiation levels around us are currently low, and here near the nuclear reactor they are going noticeably higher. We cannot see radiation in reality, but in this virtual reality a person learns where the radiation levels are higher and later applies that at workplace. Exiting this hall is once again a troublesome task for me. The portal is trying to hide from me, probably. To get a proper understanding of what's going on over there, you should study for several years at the Mafi University or really read into the instructions written by my colleagues. What else should I show you? Well, I cannot skip my own faculty, the Faculty of History. I will tell you more about what we will show you on history in our set. I hope that it is of no secret to anyone that the Faculty of History for the last 10 years has been building virtual reconstructions of historic buildings located in Moscow. This here is the cathedral of the Strastnoy Monastery. This is what we have achieved through these years. Strastnoy Monastery is not the only project we have visualized, but it's a major project still. Here we decided to cover two themes. First is the history of writing systems and printing, starting with papyruses up to modern offset printing equipment. A set like this can print a book in a matter of minutes. To give you some perspective, next to it we have put a model of the Gutenberg's printing press, the predecessor of all printing technologies. The technologies which preceded the printing press were less successful in storing information. It was fragmented. Fortunately, some of the fragments, some papyruses and scrolls have survived. The second topic we wanted to cover here is the history of aviation. The exposition starts with the Icarus myth. Next we see the plane built by the Wright brothers. They had some competitors, there were some projects developed at the same time in Russia, but the Wright brothers became the most famous plane builders. We demonstrate the modern aviation project developed in Russia and at the MSU. This is the Strizh project developed by the Advanced Aircraft Bureau in the MSU. We hope that the mass production of Strizh will start soon. Russia will receive a new single-motor aircraft suitable for pilot training and also with great prospects for export to other countries. Here you can see an unmanned aerial vehicle. This type of vehicle is used in medicine for security applications, for taking beautiful photos and beautiful videos, as you all know. One more major topic covered here is the reconstruction of the Kapova Cave. Kapova Cave is located in the Ural Mountains. It contains a number of well-preserved rock paintings. These paintings and drawings tell us the stories which happened 18,000 years ago. Kapova Cave contains a number of holes, such as the hole of the drawings, and you can see some of the drawings right here. Researchers used to think that this type of drawings has not survived on the territory of Russia. Fortunately, Russian archaeologists managed to find these drawings and are currently inspecting them and scanning them with 3D scanners. This hall consists of two rooms which represent two areas of the cave. These are the images provided to us by our partners, and they come from different areas of the cave and have some drawings on them. Vladislav Zhitinov, a leading archaeologist of the project, the head of the expedition, has given us a number of lectures. He told us that these drawings are very fragile. When the archaeologists expose these drawings, they have very little time to inspect these drawings. The paint used to create them is organic, and it quickly loses its qualities, its color. Therefore, archaeologists need to use 3D scanning to preserve these drawings, to recreate them, and to save them for further inspection.
Она быстро теряет свои свойства, то есть рисунок становится более блеклый, размывается и так далее. Поэтому благодаря вот таким вот способам фиксации мы можем это все донести в наиболее качественном варианте, и потом уже специалистам в этой области передать для дальнейшего изучения.
What I have shown you is only a part of the activities available at our set. Look, we have a guest over there. There are a number of halls I haven't covered, and I will end this tour with the demonstration of the hall dedicated to gravity. This is an unusual hall. Here we demonstrate gravity on various celestial bodies. For example, to understand how gravity works on Mars, we can use this wall, and we see that the rock thrown from an altitude, which is the same altitude for all three zones here. On Mars, the fall time is a bit more than a second and a half. On the Moon, in turn, a stone falls from the same altitude for 2.3 seconds, as we see. On Earth, the fall speed is the fastest. Thus, we understand that the gravity on Earth is the strongest one. Obviously, we understand the notions of gravity and the differences of it, but this is a visual demonstration. Now let's find the exit.
Думаю, на этом можно закончить, а сейчас мы видим, как человек перемещается из одного места в другое.
I think I will conclude our tour now. We can see a man going through the portal. Any user of the set can do this. If you come to our set with your friends, you can travel together. In some of the halls, there are special activities for groups, as the one we have seen in the N+ hall. A group can build a blood vessel together or study mathematical concepts together. These cubes are a reference to the previous science festival, which was dedicated to the periodic table of chemical elements developed by Dmitry Mendeleev, which was a major topic of the previous scientific year in Russia. I think our tour is complete now. Thank you for your attention. Enjoy using the set.